Hello, Mr. Hairston. This is Aiden Asari, and this is my honors chemistry final video project. I'll be talking about thermodynamics. Thermodynamics. So, what is it? Thermodynamics is the study of energy and how it transforms. More specifically, I'll be talking about enthalpy, which is the heat of a reaction or process. The equation for enthalpy is H equals E plus P times V, where H is enthalpy, E is the internal energy, P is pressure, and V is volume. So for reactions or processes, all of them either gain heat or lose heat. So during an endothermic process, the system absorbs heat, which means the change in enthalpy is positive, whereas in exothermic processes, the system loses heat, which means the change in enthalpy is negative. I'll be applying enthalpy to the water cycle. First, water evaporates into gas. During this process, water gains heat, so the change in enthalpy is positive. So the process of evaporization is endothermic. After the gas condenses back into a liquid here. During this process, the gas loses heat, so the change in enthalpy is negative, which means the process of condensation is exothermic. After the water falls back over here into rivers or streams, and the cycle restarts. However, in cold places like the mountains, ice goes straight to gas in a process called sublimation. During this process, the ice gains heat, which means the change in enthalpy is positive. So the process of sublimation is endothermic. After the gas goes back into ice during the process of deposition. During this process, the gas also loses heat, so the change in enthalpy is negative. So the process of deposition is exothermic. To make it more clear, we'll look at the phase change diagram of water. So first, in the regular water cycle, water, which is a liquid, evaporates into gas, and then the gas condenses back into a liquid. However, in cold places, ice, which is solid, turns into a gas, the process of sublimation, or freezing, or just sublimation. And the gas turns back into a solid during the process of deposition. For water, specifically for water, each change in the state of matter has a specific increase or decrease of heat. So this is called the heat or enthalpy of formation, which is the heat change that accompanies the formation of a substance. So for water, melting / fusion, the change in enthalpy is 6.01 kilojoules per mole, where in the opposite reaction, or opposite process, freezing / solidification, the change in enthalpy is negative 6.01 kilograms per mole. For vaporization, the change in enthalpy is 40.67 kilojoules per mole, whereas in the opposite process, in condensation, the change in enthalpy is negative 40.67. And finally, for sublimation, the change in enthalpy is 47 kilojoules per mole, or kilograms per mole. In the opposite process, deposition, the change in enthalpy is negative 47 kilograms per mole. Thank you for listening.